Okay, Algebra 2 fans, our topic for today, Notes 5-1, solve quadratic equations by factoring. And our objectives today after this lesson, students should be able to solve quadratic equations by factoring. Before we start, let me give you your joke of the day. What did Sushi A say to Sushi B? The answer is wasabi. What's up, B? Okay, there you go. A quadratic equation, so let's go ahead and start here. Quadratic equation is in the form y equals ax squared plus bx plus c. And the ax squared term is called the quadratic term. The bx term is called the linear term. The middle is the linear. And then the c, which does not have a variable, is the constant. A, B, and C are just numbers. They're real numbers. The key for this, what we're going to be doing today, is called the zero product property. For any real numbers A and B, if A times B is equal to 0, okay, so think about this. If you have two numbers that you multiply and the product is 0, one of these has to be 0. Okay, it has to be 0 times a number, or it has to be a number, and I'm just putting a number symbol, a number times 0. That's the only way you get a product of 0. So when you multiply and one of those numbers is 0, or both of them, then that's how you get 0 as the product. So for any real numbers A and B, if A times B is equal to 0, then either A is 0, B is 0, or both, A and B. They can both be equal to 0. So our strategy for today, to solve by factoring, we want to set the equation equal to 0. In other words, we want the quadratic term, the linear term, and the constant term all on one side of the equation, and we're going to set it equal to 0. Now we're going to then factor the polynomial. So we're going to get parentheses times parentheses, most likely when we factor, is equal to 0. So we're going to be using factoring, but now we're going to be using it in an equation. Set each factor equal to 0. So once you get the two factors, either this one is 0 or this one is 0. Solve for the variable, check your solution. Okay, this will make more sense when we actually get to a couple examples here. The problem, if I said x squared plus 3x plus 4 is equal to 0. In the past, what we would try to do is you would move the constant to the other side. So x squared plus 3x equals negative 4. But where do you go from there? We can't divide by 3. We can't take the square root of both sides. We could say, all right, I'll subtract 3x. And you get x squared equals negative 4 minus 3x. But now what do? Now you have x's on both sides. So in other words, the old idea of trying to move everything to the other side except the variable, it's not going to work when you have a quadratic equation. And a quadratic means x squared is your lead term. All right, so let's look at number 1 here. Solve each equation. Now number 1, notice, is already factored. A minus 8 is a factor. Okay, so I'm going to write that's a factor. A plus 6 is a factor. When you have parentheses times parentheses, for example, if you have, let's say, 2 times 3 equals 6. 6 is what we call the product, but the two numbers that multiply to get you that product, those are the two factors. So in this case, the product is 0. And the two factors are a minus 8 and a plus 6. So these are two separate factors. Well, what we know, when you have parentheses times parentheses equals 0, one of those has to be equal to 0. So what I do, I'm going to take the first factor, a minus 8, and say, okay, let me set it equal to 0 and solve it. Plus 8, and we get a equals 8. But we have another factor, a plus 6. Maybe that one is the 0. So what I do is I take that factor, I set it equal to 0. So I just write the equation. Now I solve minus 6 minus 6. A is equal to negative 6. Now what happens here, we have two solutions. If I take 8 and I plug it back in, the first parentheses would be 8 minus 8, which is 0. I'll put it on the side. And then 8 plus 6 is 14, but that doesn't even matter because 0 times anything is still 0. So that number checks. That's a solution. A equals negative 6. Well, I would do negative 6 minus 8, which is negative 14, times negative 6 plus 6, that's equal to 0. Anything times 0 is 0. So both of these make the equation equal to 0. Both of them make it true. So we have two solutions. The way I'm going to write this is A equals, and I'm going to write a bracket, a solution set. We have negative 6 and we have positive 8. Those are our two answers. Okay, so the idea is to get it into a factored form, because then we can play the game and say either the first factor is equal to 0, solve it, or the second factor is equal to 0, solve it. All right, number 2. Notice that we don't have parentheses here. 3c squared minus 6c is equal to 0. We're still going to factor this. Now, when you factor, you're always going to first look for the greatest common factor, GCF. What can we factor out of both of these? Well, for 3 and 6, we can factor out a 3. C squared and c, we can factor out a c. So what I do is I'm going to pull 3c outside of parentheses. So that right there is my GCF. Now when I divide out a 3c from that term, when I factor that out, I'm still left with a c to the first. And then over here, this would be minus 2, and the c's will reduce to 1. So there's the equation. Now we have two factors. 3c is a factor. C minus 2 is a factor. So we're saying this times this has to give us 0. So either the first factor is equal to 0, or the second factor is equal to 0. And now you solve it. Here we would do, that's 3 times c, we would divide by 3. Now it's a normal equation. 0 divided by anything is 0. And we need to move the minus 2, we'll go plus 2. We get c is equal to 2. So we get, again, two solutions. We get 0, 2. This is not an ordered pair, it's not x comma y. That's why we use the bracket and not the parentheses. Now again, you can always check this by plugging in your answer to the original problem. So I'm going to take a 0 and I'm going to plug that in everywhere I see the letter c. So 3 times 0 squared minus 6 times 0. I like to use parentheses instead of the times symbol. Now it should give us 0 as a value. It does, so that's an answer. How about positive 2? Well, we'll do 3 times 2 squared minus 6 times 2. Does it give us 0, the right-hand value? Yes, it does. So both those answers check. Number 3, what happens if we have a trinomial? X squared, the middle term's 4x, the linear term, the constant's negative 5. Well, we're going to factor this. On the side, what we're looking for are two numbers that multiply to negative 5, that's the constant, and that add up to the middle term, which is positive 4. Now we've got some choices. Actually, well, the only factors of 5 are 1 and 5. But to multiply to a negative, one of these has to be negative, the other's positive. So to add up to a positive 4, we're going to do negative 1, positive 5. That's going to be our winning combination there. Negative 1 times 5 is negative 5. Negative 1 plus 5 is positive 4. So these are going to be, we can write the factors as two binomials. X minus 1 is the first factor, x plus 5 is the second factor. And now this is an equation, so it's equal to 0. We've just finished factoring in our lessons. So we're going to factor here, but we don't stop. Those are the factors, but they're not the solutions. -1 is not a solution. +5 is not a solution. But now that we have it factored, we have a factor times a factor, and the product is 0. That means that one of these has to be 0. So we're going to say maybe x minus 1 is 0. We're going to set that up. Or maybe x plus 5 is 0. Now we'll solve them. We'll go +1, +1. So x is +1. And here we would go -5 on both sides. X is -5. And if you check those, both of them will work. So we get x equals solution set -5, 1. And that's it. So you kind of see the idea here that we want to try to factor it, and then we solve each factor. We set each factor to 0 to get the solution. All right, number 4. 2d squared minus 5d is equal to 12. Before you start factoring, okay, let's come back up here. The first step is to set the equation equal to 0. Before you start moving things or factoring things, we have to have this whole thing equal to 0. Now, I could move 2d squared minus 5d to the right side. What's going to be easier in this case is to move the 12. So I'm going to subtract 12 from both sides. Sometimes you'll see me kind of put this line straight down here to separate the left side from the right side. You don't have to do that. But in this case, I'm going to copy what we have, 2d squared. Now, minus 5d minus 12, we can't combine those because they're not like terms. So we're going to write minus 5d minus 12 equals 0. Now we have this in a form that we can factor. So let's look at the trinomial. Can we pull anything out of all three of these to start, a GCF? And the answer is no. There's no common factor besides 1. So we're going to factor this. This is a case where we can do this by grouping. So what the first step is do 2 times negative 12 on the side. So we get negative 24. So what we're looking is for two numbers that multiply to negative 24 that add up to the middle number, which is negative 5. Now 24 has a lot of factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. We need a combination that multiplies to a negative 24 that adds up to a negative 5. I'm going to use 3 and 8. Now one of these has to be negative. The 8 is the negative. Okay, 3 times negative 8 is negative 24. 3 plus negative 8 is negative 5. Now I'm going to take that, and because I'm going to group here, I'm going to rewrite the middle term using the 3 and the negative 8. So we have 2d squared plus 3d minus 8d minus 12. And I'm not going to worry about the 0 for now. Let's just factor. So we're going to group the first two. I can factor a d out, which leaves me with 2d plus 3. And then the second group, I'm going to factor out negative 4 minus 4. If I divide by negative 4, I get 2d plus 3. Now, both of these have the 2d plus 3. So I factor that out, which leaves me d minus 4. Now it's equal to 0. Now that we factored, take each factor. So 2d plus 3 equals 0, or d minus 4 is equal to 0. So we'll go minus 3. So 2d equals negative 3. Divide by 2. Okay, I know I'm kind of running out of space here. So d equals, on the side, negative 3 halves. Here we'll go plus 4. And we get d is equal to 4. And those are our two solutions. Okay, again, if you check them, it would have to make this equal to 12. So you should always check. And that's the end of part 1.